Well, this video is for Math 112, and this is about Project 2. So there's another video where I go over some sample problems that are similar to these. One of them has a paddle wheel. On the project, you can see we're working with a Ferris wheel, so those will have some similarities. So this, we'll see how long it takes to go through this. Like I said, because of that previous video, I'm not going to do a whole lot of explanations here. So the key things that we need to identify are the maximum and minimum values. That will allow you to calculate the values of A and D, right, if we're working with the A sign. Now I know in the previous video I pulled the B outside the parentheses because it makes it a little bit easier to work with. You can do it with that BX plus C format if you prefer. I found that this is a little bit easier. Okay, so that'll allow you to find A and D. So choosing the starting point, right, this S value, right, the sine function, it starts at the midline value, okay, and the cosine function graph starts at the maximum value. So if you want to start your function at a maximum value, then you should use a cosine. If you want to start it where the midline hits, then that can be a sine function. Let's see here, what else? Right, the period. Identify the period, and that's given to you in the problem. Let's see here, everything's given in seconds, so it's good to pay attention to your units, make sure you're using the same units. I think in this problem the distances are all in feet and the times are all in seconds. Let's see here, and then so the period allows you to find B, and then like I said, picking your starting point depends on whether you want to write this as a sine function or a cosine function. Okay, so that's part A. Part 1A is to write that equation, and these are all the key factors that you need to write that equation. So when it comes to graphing, if you use Apple computers, they frequently have what they call a grapher. If you search your computer in the Finder under grapher, you should be able to find an excellent graphing calculator application on the Apple, and you won't need to use Graph or Desmos. Let's see here. What else? Part C is just going to come out once you write the equation. You're just going to get y values for those x values that I've given you. Let's see here. So part D, let's see. So this gets into the question of the multiple answers for trigonometric equations that we kind of were talking about at the end of chapter 3. So this question 1D says, what is the value of t the second time you are 18 feet off the ground? So whether you're using a cosine or a sine graph, doesn't matter. Let's see. It's going to look something, let's see, at t equals 0, it's on the way up to the maximum. See, I think it's going to be something probably like this, okay? Although, let's see, so this is the midline value, and down here is going to be where y equals 0, because the height of the Ferris wheel chair is never going to be 0. It's all, the minimum value is going to be greater than 0, and I address that in the project. Okay, so where is it going to be 18 feet off the ground? So off the top of my head, I'm not sure whether that 18 is more or less than the midline value. Let's see here. Let me see I can figure that out quickly here with the diameter being 50. Right. 25. Yeah, so I think the 18 is going to be along here somewhere. So you can see there's a series of places where the chair on the Ferris wheel is 18 feet off the ground. And so this question is asking for the second time. So if you look at the graph, I think it's a little bit easier to do this, to solve this by graphing it, right? Now, if that 18 intersects here, then this would be the second time. If it doesn't intersect there, then this would be the second time. So you'll have to make the graph and figure out which one is the second time. In some situations, the value of time, whether it's positive or negative, doesn't make a whole lot of difference. In this problem, it does, because the Ferris wheel is stopped up until t equals 0. Okay, so it does. This graph does not go backwards like this. It starts at t equals 0. Okay, so that's part 1. If you have any questions about it, let me know. I'm happy to talk to you about these problems. That's why I choose them, is because I like to talk about them. All right, let's look at problem 2. Let's see, I think I'll put the diagram up first. We've got this diagram for a formation, a mineral formation under the ground, and which kind of makes sense if the minerals are molten to start with, then they're going to move in these wave-like patterns, and they may harden in waves. So it's not unreasonable to assume that that can happen. Let's see here. So what are we looking at? Yeah, so a hole drill. Well, this comes later on. We've got a hole drilled at x equals 200. Comes down to about here, and then we've got a y value that coincides with that. But to write the equation, we need to get some information here. This actually, I think that this will be helpful in writing the equation, because you're going to have some missing factors, and if you plug in these x and y values, then that'll help you to write the equation. So yeah, actually that will be important. Let's see here. The formation is parallel to the ground, so one full cycle occurs between negative 400 and positive 800. So that's here, and so that distance is the period. Okay, so that'll help you to find B. Let's see here. Formation has eroded away, but would reach its maximum value at x equals negative 200. So whatever that maximum y coordinate would be, it's going to happen halfway between the negative 400 and the 0. So that's where the maximum value is going to fall. And then we've got another point on the graph. We know that the point 0, 0 is also on the graph. And then this point right here is 200, negative 180. So like I said, we don't have quite as much direct information about the maximum and the minimum in this problem, but we do have these two coordinates given to us, and that will allow us to solve for those points. So anyway, this value of negative 200, right, saying that that's where the maximum value is, so that's a clue about a starting position and whether you might want to use a sine or a cosine function. And I won't say a whole lot more about that. If you ask me about it later, we can talk about it some more, but I'd like to give everybody a chance to think about it before I just give things away. Okay, So all of that information that I just addressed is really important and useful in writing the equation. That's part A. Let's see. Part B is again just taking an x value and finding a y value to go with it. What's the maximum depth? So we want to know that minimum value there. What is the max? What would have been the maximum height? Okay. What values between 0 and 800 is the formation within 120 meters of the surface? Okay, so you'll have an inequality to represent those regions. There's going to be some intervals. And then the last part, part F, the idea is that the geologists want to drill holes to the top of the formation every 50 meters, from 50 out to 750. So the idea is that you want to calculate the depth of each of those holes and then assume that each of those holes costs $75 per meter to drill. And then we'll get a final cost for that. So I encourage you to use a spreadsheet for that. You know, if you've never used an Excel spreadsheet, this is a good time to learn. They're extremely useful. And the idea here is that you want to make a table where your x's are starting at 50 and going up to 200. Now, I'm writing these all in, but when you're working on a spreadsheet, you know, there's a neat trick that you can do where you fill in the first one as 50, and then for the next one, you just say the previous one plus 50. Let's say, you know, if this is A2, then we would say A2 plus 50, and then you can just drag this down until you get to 750. Okay? Then for the y values, again, you can hand calculate them if you want to. You can read them off your calculator if you want to. I would encourage you just to type the function into that cell there, and instead of using x, you want to use this cell in place of the x. Okay, that would be very helpful. And then let's see. Then we want to add all these up. There's a sum function in the Excel spreadsheet. And it would say, you know, you want to sum from B2 down to wherever it ends. And that would give you the total of all the drilling. And then just take that number and multiply it by 75. And that would give you a total cost. So there's a lot of really interesting things I think that you can do with an Excel spreadsheet. And I encourage you to do that. You know, it's really useful. It's actually one of the it's one of the most common places where people apply algebra in the everyday world, is in using spreadsheets. And you can see that's what I'm getting at here, is that the variables, right, are gonna be appearing in those cells. So if you get stuck with the Excel spreadsheet, let me know. I'll be happy to help you out. If you just don't want to do it and you'd rather type it all in, that's up to you. It's more work to do it this way than it is to do it this way. And of course, if you do it this way, this is your opportunity to learn how to do this. Save yourself some time going forward. Okay, so I think that's it for problems 1 and 2. Like I said, you've got those other sample problems to look at. And I know problem 2 is a little bit different because there's not really any information about the maximum, minimum values to help you to find A and D. But like I said, you've got these 2 points that are given to you, X and Y values on the graph, and that can help you to find those values for A and D. As always, if you have any questions, please let me know. Thanks.